Hello, this is Cody Gullickson presenting my simplified Gnutella peer-to-peer application design for the North Dakota State University CSCI 846 course, assignment number 2. Before getting into my design, it may be beneficial to explain some of the key principles about Gnutella network architecture, as well as some of the advantages and disadvantages that this type of architecture brings. There are two types of peer-to-peer architectures, structured and unstructured, with the Gnutella architecture being the unstructured variety. This means that there is no set algorithm or identification method for assigning other peers within the network. The theory behind this unstructured pattern is that each client maintains a list of known neighbors that through the course get added and removed from the network at any time. However, the clients are constantly fishing for others on the network to associate with. Based on the principle that clients can be added or removed from the network at any time also makes the Gnutella network architecture fully distributed. In a traditional client-server architecture, the server would always need to be available to clients in order to transfer any amount of data. With Gnutella, as long as there is at least one other client running the same software on the network, both clients can potentially communicate and send data back and forth. The idea of Gnutella being a fully distributed application is one of its main advantages. It no longer relies on the potential bottlenecks of the centralized server and can reach out to any client that it knows about. However, there are also disadvantages with this type of network architecture. For example, there is no guarantee that a client will ever find the data that it is requesting using a query protocol message. Since there's no centralized source of information indicating what client has what files, it is up to the query messages extending to each known neighbor in order to attempt to make this discovery. Thus, there are many downsides when querying. As clients are added and removed from the network, there's a possibility of skewing the query search by disrupting the path back to the original client. Additionally, searches can simply end with no response back to the original client if the query message exceeds its time to live duration with no matches found. Building the Gnutella network architecture, there are types of messages that we're focused on for this assignment. These include ping and pong, query, and query hit message types. Ping and pong messages work in conjunction with one another and between clients in order to maintain an accurate list of which clients are potentially available for querying when the time comes. However, as ping and pong messages are constantly sent through the network, they pose the threat of congesting the underlying network infrastructure. The query type messages are built based on what the user is trying to find within the client. Each time a client tries to look for an item, a query message is sent to all known neighbors for the client. Each of those clients compare the request value with the files they have to offer. If a match is found, the query response is sent back to the original client. Whether a match is found or not, if the message time to live has not been exceeded, the query is then forwarded on to additional neighbors known by the client at hand. If the client finds a match from the query, a query hit message type is created and sent back as the response back to the original client. This response contains all the key information, such as IP address, port, and file information that the requesting client would need to know in order to establish a direct connection and start the downloading process. Taking all of this information and more into consideration, the following is the design that I've created for building the client software application used to run the Gnutella message protocols. In addition to the Gnutella information learned, I've also built upon some of the socket connection knowledge gained from the previous assignment. Considering an object-oriented programming language such as Java or C#, I've designed the application into 3 components that interact with each other: a user interaction component, a socket handler component, and a message handler component. Starting with the user interaction component, The imposed design builds upon a command line interface capability where the user would be able to enter a keyword to search. Upon submission of said keyword search request, the application would invoke a method within the message handler class in order to build a query message with the Gnutella message protocol. Should responses come back from the query, they would be printed to the command line interface where the user would see the keyword and file along with the IP address and port of the client who holds the data. Future design changes would allow for the client to select one of those results and set up a direct connection for downloading the content. The socket handler component within this design is very similar to the socket handler component of the first assignment regarding the proxy server. During its initialization, it would stand up an open server communication port that would allow socket connections to be made to this application. Each time a socket connection would be made, the message handler component would be able to listen for different Gnutella message protocols coming into the application. Like the first assignment, the socket handler component would also be responsible for initializing the list of keywords and the list of starting neighbors. The final component is the message handler component. It'd be initialized after the socket handler component has been created and be running on its own thread. However, the message handler component would help initialize and maintain a constant run thread, a ping thread, and a query thread. Within the run thread, the message handler would be listening to the message protocols that came through the socket connection. After parsing out each message, it would determine the next course of action. If a ping message came through, it would know that it needs to build and respond with a PONG message. With the ping message that was received, the PONG message would first be generated based on the Gnutella message protocol standards and be sent back to the previous client. If the message time to live value is not yet expired, the run thread would take its known list of neighbors and attempt to forward the current ping onward, thus expanding the network for the original ping caller. However, if a query message came through, the message handler would know that it needed to investigate its keyword file to look for a match. Like the ping message, should a query match be found, the client would work on generating a query hit message based on the Gnutella message protocol standards and be sent back to the previous client. If the message time to live was not yet expired, as the run thread would take its known list of neighbors and attempt to forward the current query onward, thus expanding the search range for the original query caller. Looking back to the ping thread managed by the message handler component, this would be a thread separate from the run and query threads and only focus on establishing associations to other Gnutella clients on the network. It'd first take its list of known neighbors and build ping messages based on the Gnutella message protocol. For each known neighbor in the list, this message would be sent. At the same time, as each message is sent, a new thread would be created in order to maintain the asynchronous capabilities of outbound messages. Once all neighbors have gotten a response back, have sent a response back, the ping thread would then invoke a sleep function for a short delay to avoid flooding the network with unnecessary messages. The final type of thread managed by the message handler component would be the query thread that is created as part of the message handler component. This thread would be invoked only when the user of the application has submitted a search request. Upon the submission of a search request, the query thread would first take its known list of neighbors and build query messages based on the Gnutella message protocol. For each neighbor, this message would be sent. At the same time, like the ping messages, each query message would be sent while also creating a new thread in order to maintain the asynchronous capabilities of outbound messages. Because there is no way to know when a query was completed or if a response would ever come back, the user would be free to close all existing threads based on a cancellation within the command line interface. This in turn would close all of the subthreads built into the query thread, allowing for the user to try and research the original keyword.